Go on, give it a test there if you want.
How do you do it?
There you go. True. True. Now draw a sad face as well or something. Yeah, there we go. Okay, good. Good stuff. Good stuff. Actually, you did pretty well with that.
If I had that, I would do my homework and make my notes in bed. You know, with mine, I have to make it flat.
I did have a student last year who had a tablet and kept all his notes on the tablet. So you
Yeah,
could
I
write
can
it
do
on
that, but then my laptop, I have to flip it, and I have to like leave it like it's like this. I have to turn it around.
All
Like,
right,
you know,
okay.
the 360.
And is that not?
It's just uncomfortable because I have to write like that.
Oh, really? Okay.
Yeah,
It's not at a good angle.
yeah.
All right, okay.
But I think I have the same thing. This is bamboo.
Yes.
Yeah, it's the same thing.
Oh, is it? Okay.
It's just uncomfortable.
Okay, guys. Hey. We'll start now. Ahmed, Amjad, Mubarak, we'll start now. Guys, we're starting now. So, Ahmed, Amjad, come on. Now, last time we were looking at the product rule, which helps us get notes ready to start. You can't use your phone when you're sitting right in front of me, okay? It's too obvious. So, as I was saying, last time we were looking at the product rule, and the product rule lets us calculate the derivative of a multiplication of two functions. So there's no surprise here that the next thing we're going to look at is how to get the derivative when we divide by two functions. So for example, if I say y equals f over g, we want to calculate y derivative. And you can guess what it's not. What is it not going to be? Yeah, it's not going to be that, right? Because like last time we saw, it's not as straightforward as that. So just like last time, we will figure out what the rule is. And then when we have the rule, we'll do some examples. Okay. Have you got this title written down? So you'll need to write this down carefully. So let's say we want to calculate dy dx. Like last time, it's limit h goes to 0, and it's fx plus h, gx plus h, minus fx over gx, all over h. This is the first principle rule. So obviously we have to simplify this. Just like last time, there's nothing useful here right now until we simplify it. Okay? So the first thing is, it's a bit messy that we have double fractions here. So I think the first thing I'd like to do is at least make the top a single fraction. So this is limit h goes to 0, all over h, and it's a little bit squished here, but you remember to add two fractions, you multiply their denominators, so that's gx plus hgx, and then it's this one times this one, minus this one times this one. So it's fx plus h times gx, minus fx times gx plus h. Yeah. Yeah, that's the idea. So Mo, did you get an answer?
Yeah.
And what's the story?
You just have to repeat it again because
No IBID?
Well,
Why isn't it?
Hang on, I'm talking to Mo, not you. Don't make me slap you.
This is my issue.
I am having a conversation with Mo. Mo? What's the story?
Yeah, you just have to repeat it again. But it is a thing in the Harvard style.
And who told you have to repeat it?
Well, EAP teacher and Mr. Cohn.
Yeah, but I wouldn't trust Colin. Which EAP teacher?
Cohn.
Oh, yeah, no, he's been doing it a while. You should trust him. Yeah, okay.
So he said just repeat it. We don't do it in this college, but it is in the Harvard style.
So it is Harvard style?
Yeah.
Yeah. But it's not the IFC Harvard style.
Yeah.
It's a different style we have. Yeah. Well, you know, Colin told you about Zotero.
Yeah.
So the style template, he calls it DIFC Bio, is not exactly like Harvard. It's a slight change of it.
Yeah, but it doesn't have a repeating function in Zotero.
It doesn't?
No.
Ah, so you thought you were being Mr. Smart Guy by changing it to IBID.
Well,
yeah.
in the beginning of the year they did. Like,
Yeah, they
did
did
mention.
Who?
I clearly remember Dr. Lorraine in a chemistry assessment support tutorial.
Yeah.
Yeah, assessment support. She taught us about it a bit because I didn't know about it beforehand.
Are those lessons recorded?
Sadly, no.
Your word against hers? The thing is, for each subject there'll be a different standard. So for example, I would not expect in the maths paper you to be as strictly adherent to Harvard. So for example, if you write Harvard, you try to get it in the Harvard style. But I'm not going to be sitting there going, oh, he used IBID. Well, that's a 0 for him. You know, there's going to be a different level of strictness per subject.
One second, were we meant to use references in the math course?
No.
Well, I mean,
I don't know, man.
if you had a formula that you copied and pasted from a website, you know. But I haven't started correcting it anyways yet. Why, am I going to be in for a shock when I start?
I don't know.
Okay. Anyways, continuing. You all have this down?
Indeed.
So, the next thing we want to do is just to get rid of this, this h here. So the easiest way to do that is to multiply the top and bottom by 1 over h. So it cancels there, and the h goes into the denominator on the top. So basically it's like I can move the h up a level in this double fraction. So it's just going to be h gx plus h gx. Limit h goes to 0. And I'm going to do another trick now, like what we did last time. Fx plus h gx. I'm going to leave a bit of a space and then have minus fx gx plus h. The same thing there, squished in. The reason I left the space is I'm going to use the same trick that I did last time, where I add and subtract a function here. So what I'll do here is say minus fx gx, I think, and then plus fx gx. Okay. Okay.
Yeah.
Yeah.
It should always be minus and then plus.
I think for both proofs it was.
Yeah.
And the reason for that is because we're trying to make a derivative appear at the beginning, which requires a minus in the formula. We already have a minus in the...
Yeah.
Although...
Yeah, probably.
Did it?
No, the other one was plus, wasn't it?
I don't remember. I only remember it right, the moment right before I need to remember it.
It was the same.
Was it?
Yeah.
Okay. Can I scroll down a bit? I can't scroll down? Oh, okay. Hmm? Daniel? I just want to scroll down one level.
Yeah.
Okay. So if you look at the first two, what can I take out? What's in common?
FX, GX.
fx. No, not fx. gx. there's only a gx that's in common to the first two. And then what I'm left with is fx plus h minus fx. Now what I'll do next is I'll take out minus fx. And I'll start at the back. So if I take minus fx out of the back one, what am I left with? Gx plus h. And if I take it out of the front one, what am I left with?
Minus gx.
Very good, minus gx. Now what I'll do is, this is all over h, okay? So I'll put each of these guys over h separately. And it's also all over g. So I'll put the whole thing, not g, but the two g's there. So I'll put them out separate. Now you might see why I've separated it like this, because what happens to the red brackets? So what does this one become? What's this one becoming? F derivative. And this one? And what will this become? No. 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 G squared. G squared. When the h is 0. Right? Right? So this is gx f derivative minus f g derivative all over g squared. Yeah. Got that? Got that? Scroll up. But you told me you had the last one. Okay.
So if in a quotient equation,
Yeah.
which one is the fx, which one is the g?
We'll make it clear now in a second. Yeah? Scroll down a level. So what I'm saying is, Mo, if it's a function over a function, f over g, so the f is the top one, the g is the bottom. The derivative is, this is how I remember it, the bottom squared, the bottom times derivative of the top, minus the top times derivative of the bottom. That's the quotient rule. Now we'll look at an example, of course. Amjad, are you listening? Did you write this down? Do you not want to at least write down the rule, which is the most important rule for today? And have you done that yet?
I see you don't give them slack for not writing.
Yeah, well look, there's many things wrong with Amjad, so I just couldn't remember. Oh, did you hear that? Sorry. You know, cut the guy some slack. Look at his hair. Right, continuing. Question, guys? Arya? Angela? Question? No, you sure? Right, well, what's most important now are some examples of using this rule. So, first example. Let's say we have a function like y equals tan x, where tan x is what? Sine over cos. Yeah. Now, the reason I picked this one is because we actually know what the answer should be at the end. What are we supposed to get at the end? 1 over cos squared. Let's test it. So, the derivative of sine over cos, the rule is, it's the bottom squared. Okay, so far so good. The bottom times the derivative of the top. What's the derivative of sine? Cos. Minus the top. And what's the derivative of cos x now? Minus sine x. So you have a double minus here, so it becomes plus. Now what is cos squared plus sine squared? 1. So this matches up perfectly with the rule we were given in semester 1. Okay, we'll do a couple more examples now. That's our first one. I've seen a question like that in the exam. You know, they would say something like, something like, prove using the quotient rule that derivative of tan is 1 over cos squared, which is just a fancy way of saying get the derivative of sine over cos. Yeah? Okay.
So 2 cos x and 2 sin x is 1?
2 cos, huh? Well, cos squared plus sine squared is 1.
Oh, okay.
Can I do another example? Yeah? Okay, so next example, y equals sine x over x. Okay, so the rule is, not just yet, I'll do a couple more examples. Bottom squared, bottom times derivative of the top, minus the top times derivative of the bottom. What's the derivative of the bottom? Derivative of x?
1.
1, so it's just sine x. Yeah? Got that?
Is it the same as in the product rule where it doesn't matter if we simplify or not?
Yeah. Yeah. Huh?
Can't simplify that.
Yeah, you can.
There's nothing really to simplify here for this one.
You can put x cosine x over x and then separate the denominator.
Yeah, but that's not really
Simplify.
too helpful. Okay. Here's a harder one now. Harder one. Guys, listening? X sine x over EX. No, not EX. Let's go with, okay, log x. I didn't want to, but okay. Log x. Right. This is a little harder, though. Why is this a little harder? Just a little harder.
1 over x?
No. My question is, why is this a little harder?
Linux.
No, that's okay. Huh? No, you can.
Oh, the x sine x on
Did
the top.
I don't think anybody ever said you can't square log x.
The x sine x, you'd have to use product.
You have to use product rule on the top. So, because it's a product on the top. Now, please watch carefully, because a lot of students don't say it. If I said to you, what do you do first, product or quotient rule? I'm sure 3/4 of you are thinking the first one is the product rule. So it's not. The first rule here is quotient rule. Okay? So watch carefully. First we need the quotient rule because it's a quotient, a fraction. So it's the bottom squared. Okay? The bottom times the derivative of the top. Now what have we just initiated here? Product rule. So now derivative of the top. So that's first one differentiated, second one the same, first one the same, and the second one differentiated. Now we can return back to the quotient rule. Bottom squared. Bottom times derivative of the top minus the top times the derivative of the bottom, which is what? 1 over x.
Simplify it.
You can cancel the x, but we won't bother.
What about the square?
What about what squared? This square?
Yeah.
What about it?
Then x squared is 1 over x squared.
No.
G squared.
This is the g squared. What do you ask me? No, what's your question?
No, like what's the derivative ln x
1 over x.
and ln x squared?
I don't need the derivative of ln x squared. Because if you look at the formula which you wrote down, it's just g squared, not g derivative squared.
Oh, okay.
See how writing things is helpful? And understanding things too. Okay. Let me give you one to try now. I'll give you two. Just to practice. Let's say I have y equals log x over x. And let's say I have y equals ex over x log x. try those two. No paper?
Yeah.
In AP Calc, there used to be a huge focus on simplifying.
Yes. Are you asking me something?
We don't need to simplify whatsoever.
You 90% of the time, no. You have one question left. I deliberately tricked you into making that last statement a question. You know I did. Huh? No, just go back to sleep. Go back to sleep, please. Thank you. All right.
I've still got 2 questions.
Not one. Unless that one counts as the last
That's what the
question.
statement.
Ah.
I've got 2 questions left.
Question mark.
Yeah, you could have said it like after.
No.
No, it wasn't like, I've got 2 questions left. It was, do I? That's right. If you use up all my questions, you can ask Amjad. No problem. He'd be happy to help, right? Yeah. Okay, have you got the first example done? Yeah. Do you have enough space there?
Yeah.
Yeah?
Derivative of EX is XEX.
Derivative of EX is EX. Okay, let's have a look at the first one. So the first one is straightforward, I hope. Bottom squared. Bottom times derivative of the top. Minus the top times derivative of the bottom. So just 1 minus log x, yeah. Okay? Next one's a little bit harder. EX over x log x, derivative, equals. So it's the bottom squared. The bottom times derivative of the top, which is EX, minus the top times derivative of the bottom, which now requires product rule. So that's x derivative, which becomes 1. So 1 log x plus x times derivative of log x, which is 1 over x. No need to simplify. That's the answer there.
We don't use simplifiers.
Usually not in the exam.
Even the code of proof.
Yeah, usually not. In fact, they might even say in the question, do not simplify.
Stop asking the same question.
I know. You want to use it up?
I have 8 questions in my bank account.
No, transfers aren't allowed, sorry. I don't want a marketplace where you're selling questions for others to use, okay? What? Do you want to use it up?
That was my question.
Humanity, okay. Another example, do you have this written down? Yeah.
We need to simplify it, and we take e over x as.
Yes. Yeah. Okay, can I scroll down? Yeah? Okay, let's scroll down. So, let's have a look now. Let's see. Let's have a look at how difficult, I just want to see how hard I make these. Yeah, okay. Just another quotient rule I want you to have a look at. It should only take you like a minute maximum. This is a quotient, 1 over 1 minus x. Now be careful, just remember what the derivative of 1 is on the top. So just take a few seconds to differentiate this as an example. So I want the derivative of this. Okay, so the bottom squared. The bottom times derivative of the top, which is 0, minus the top times derivative of the bottom, which is minus 1. So we're left with 1 over 1 minus x squared. A typical follow-up question, if you imagine this as being part 1, or might all be together as one, they might say, prove that y equals 1 over 1 minus x is decreasing. Yeah? That's true. No, that's true, yeah. But using calculus, how could we do this? Well, we've just worked out the derivative, didn't we? And that's equal to 1. I feel like we made a sign mistake.
Yes, you do.
Yeah.
If you double check it,
The bottom times the top minus the top. No, it's right.
I got -1 as well.
no, it's not.
What does the graph of this look like, Mo? Can you bash it into the graphing calculator?
Which one? The original?
The 1 over 1 minus x, yeah. Bottom times root to the top.
If you do it with row when I last semester.
Wait, there's... Yeah, okay. It's... I said something wrong here. I was picturing the graph incorrectly. This is actually increasing. Increasing, not decreasing, which is a bit weird. Because you were saying as the x increases, yeah. I'll put the graph up for everyone to see now in a second. Anyways, back to my question. How could we show that this is always increasing? Well, we've worked out the derivative. Not necessary for, not necessary, no. That's the derivative. Yeah? Wait 1 sec. Isn't it?
No.
What?
Oh, yeah.
It's the same thing, yeah. No, the reason I just wrote it like this is to really emphasize a point. We know something about this. It's always positive. Now, what does the derivative represent on the graph?
Slope.
The slope. And what does a positive slope represent? Increasing. So the fact that the derivative is positive means that the graph is increasing. Now, it's increasing in kind of a strange way because it's kind of going like this, wasn't it, on your...
And the other one.
And there's another one on the left, yeah. I'm just focusing on the right for the moment. You know, if x is bigger than 1, we'll say.
But it's under the x-axis.
Yeah, it's negative, so that's why it looked confusing. I'll show you here, Amjad. 1 over 1 minus x. So do you see, here it's increasing. But even here on the left, it's still increasing. No matter where you pick, you're always at a point that's increasing. See, like if I was here, the slope is positive, so it's increasing. If I was here, the slope is positive, so it's increasing. If I was here, it's positive, so it's increasing. So it's always increasing because the derivative is always positive.
No, but if you talk about when you divide by a greater number,
Say again?
when you divide by a greater number,
Yeah, but it's not a greater number, it's a smaller number, because it's 1 minus x. Yeah. No, you're making that face where you're thinking too hard about it. Let me make it simple for you. I have 1. No, listen. I have 1. Will I make the number 1 bigger or smaller if I take more away? Correct. So, as the x gets bigger, 1 minus x gets smaller. So the denominator is getting smaller. So the fraction then is getting bigger. No. The function is 1 over 1 minus x. No. That's the derivative. I'm drawing the original function here. Do you get it or not?
Yeah, I thought it was about the
No, I'm not drawing the derivative. I'm drawing the original. Okay? Yeah.
I think your first derivative has a sign on.
You think there's a sign mistake? Well, let's confirm it. Derivative, simplify, no. I can believe I'm wrong, but I can't believe my computer's wrong.
If you did that with
I didn't give you any rule from first semester for differentiating this.
just convert it to the power of -1.
No, that doesn't work. That doesn't work.
Why?
Because it's not, that only works for this. That doesn't work for this. I never gave you a rule for this.
It's x minus 1.
Yeah, it's different. It's a different function.
Wait,
Yes,
x minus
1 minus x. Okay, now, I'm going to start putting limits on your questions too now, okay? So just,
And the computer was x minus 1.
yeah, but x minus 1 is the same as 1 minus x when you square it. You know this, don't you? 1 minus x is the same thing as x minus 1 when they're squared. Yeah.
Can you scroll up?
Yeah.
What about if it was squared? Would it be increasing the screen?
If what was squared?
1 minus
If it was all squared?
yeah.
It would still be increasing.
Well, let's just make the graph and see. You're saying, Amjad, if you square this, what graph will you get? No, so it'll be increasing as long as x is less than 1, and then if x is bigger than 1, the graph decreases. Yeah. That makes sense, huh? Okay. Okay, did you write this down? Yeah? So this is what I was saying last time. In the exam, it's a little bit too short if they give you a question that just needs 1 rule. So usually in section A, the question needs 2 rules. So this is an excellent example, this last one here, like x sine x over log x. Because you need the product rule and the quotient rule. So this would be very typical of the exam. But even this you can see you can do quickly. You just have to be really careful about which rule you're using when. But it's actually a short enough question to do once you have the rules memorized. Now these rules are in the formula book, but I promise you, your life will be much easier if you just can apply the rules automatically without having to check the formula book, you know. So I kind of remember it, I think I told you this, the way I remember the FG one is I imagine the derivative runs across the top. So it's f derivative g and then plus fg derivative. So I visualize this moving along, differentiating as it jumps between each function. And the way I remember this is really just as like as a sentence. Bottom squared, bottom times derivative of the top minus the top times derivative of the bottom. That's how I remember it then. Now, like I said, it's in the formula book, but your life will be much easier in the exam if you have these memorized. Okay? So for the last 10 minutes there, I'll let you practice some of these, all right? Some of them have The questions that have product and quotient in it, they're really the most important ones because they're exam style. So that's like number 2 here, where it's a product and divide. So these are exam difficulty. These ones here. These ones are a little bit too straightforward for the exam. I can close this? Do you need to go back to the last question?
No, I have a question.
So,
Yeah.
I need to confirm with this.
Yeah.
We don't need simplify the final answer.
Oh my goodness, will people stop asking me this? No, you don't need to simplify it.
I have to ensure that because I don't want to lose my
Yeah, but... Okay, young Peng, I'll tell you what. Usually when I say something 5 times, it's a lie. It's only when I say it for the 6th time it's true. You found out my secret.
We thought the bid was true. Little do you know.
Just
Yeah.
name the video.
Yeah.
You name the video. You do not need to.
That's not a bad idea, actually. Yeah.
You do not need to simplify the final answer.
That's not a bad idea.